येतो सर, येतो आवाज.
हॅलो.
विद्यार्थीचं काय आहे? तेच असेल पहिले विद्यार्थीचं.
हॅलो. मोबाईल वरच करू चार्ज.
दोन कपडे
तो सुरू झाला सुरू झाला
हॅलो 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 हॅलो
बोला सर. नाही लेक्चर नाही, एक आमचं ते वेबिनार चालू आहे. आता चालू केलं होतं त्यांनी. त्याच्या मनानं आपली तयारी चांगली होती. आपण एकदम ज्या त्या वेळेवर एकदम रेडी राहतो. इकडे हे लोक तू चालू कर हा
आपल्याला 2 दिवसापासून काय हॅलो हॅलो
हॅलो हॅलो सर, करडे सर. हॅलो
हॅलो.
हा करडे सर, तुम्हाला
हा
आवाज
मॅडम.
येतोय का?
हा येस येस आय एम रिचेबल. येस.
आणि प्रदीप टेकाडे सर.
येस मॅम येस.
हा तुम्हाला पण येतोय ना आवाज?
येतो.
हा ठीक आहे ठीक आहे. थोड्या वेळात सुरू करते सर.
हा मॅडम.
डॉक्टर राहुल
नमस्कार टेकाडे सर, नमस्कार.
हा नमस्ते सर.
हेलो 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 हेलो
येते का मॅडम?
हॅलो तुम्हाला येते
Yes, madam. आवाज yes, yes.
मॅडम सुरू करा.
हॅलो
हा येते.
हॅलो
Yes, madam. You are audible.
Hello, hello everyone. On this beautiful morning, I, Dr. C.N. Deshmukh, from Department of Chemistry, Vidya Bharati Mahavidyalaya, is pleased to welcome you, each and everyone, for this webinar on the topic Future Scope of Chemistry in Research. And for this, we have eminent resource person, Professor Dr. Nandakishore Karde, Department of Chemistry, RTM University, Nagpur. He is going to deliver lecture on the topic Hypervalent iodine reagent in organic synthesis. And Dr. Pradeep Tekade, Department of Chemistry, Bajaj College of Science, Wardha, and his topic is plagiarism and bibliographic citations. So this is the schedule. And now I would like to request Dr. V.V. Parate, Head Department of Chemistry, Vidya Bharati Mahavidyalaya, to deliver her introductory speech.
Very good morning to one and all present here, and thank you for joining us. Honorable Rasab Shekhawat, President of Vidya Bharati Shekshanik Mandal, Honorable Dr. A.D. Chauhan, Secretary Vidya Bharati Shekshanik Mandal, Honorable Manjiri Shekhawat, Chairperson Vidya Bharati James, Honorable Dr. P.S. Enkar, Principal Vidya Bharati Mahavidyalaya, Dr. Aryam Patil, IQAC Coordinator, Professor Captain Mithilesh Rathod, Coordinator of Research Committee, Resource Persons, Professor Nandakishore Karde and Dr. Pradeep Tekade, all participants, all head of the departments, teachers, students, and organizing committee members. I welcome you for this webinar. Friends, as we all know that the world has changed with the outbreak of COVID-19, the education system has witnessed its severe negative effects. Therefore, to fulfill the gap, the Department of Chemistry, Vidya Bharati Mahavidyalaya, Amravati has organized this webinar. This webinar is intended to bring prodigious researchers, teachers, and students together to upgrade the new avenues of chemistry to augment future scope of chemistry in research. I hope this webinar, with gracious presence of Professor Dr. Nandakishore Karde and Dr. P.V. Tekade, is going to thrive in its purpose, because these sessions are interactive in nature, thereby allowing you to share your queries and doubts. I am very much thankful to the management of the college, principal, and IQAC of the college for providing me support in every way. As a head of the department, I take this opportunity to extend my sincere thanks to Professor Nandakishore Karde and Dr. Pradeep Tekade for accepting our invitation to grace the occasion as a resource person. I hereby again welcome all, and I am thanking also for your support in this event. Thank you. Thank you very much.
Madam, now I would like to invite Dr. P.S. Bodke, to give a brief introduction of our speaker, Professor Dr. Nanda Kishore Karde. Dr.
Good morning to all of you. It's my great pleasure to introduce to you an eminent scientist, Dr. N.N. Karde. Presently, he is working as a professor in RTM University, Nagpur. He did his PhD in 2005 on the topic development of synthetic methodology for functional group transformation from the Swami Ramananda Tirtha Marathwada University, Nanded. His area of research, application of hypervalent iodine reagent in organic synthesis, multi-component reaction for the synthesis of heterocyclic compound, synthesis of natural product, cross-coupling reaction of iodinium salt. He published more than 57 research publications in international peer-reviewed journal. Under his supervision, 9 students awarded PhD and 2 students under working. He reviewed the prestigious journal like Tetrahedron, Organic Letters, Chemical Communication, RAC Advance, Synlate, Bioorganic and Medicinal Chemistry Letters, RSC Advance, Synthetic Communication, Current Organocatalysis. He has a teaching experience of 24 years at post-graduation level. He is honored with the Gold Medal Award in 1994 for securing the highest rank in chemistry. He stood 4th merit in BSc. He qualified SET, NET, NET JRF and GATE exam with 90.95 percentile. He had worked as a coordinator for UGC SAP from 2015 to 2020, and grant sanction in this period is 1.38 crores. He completed more than 8 major projects sanctioned by DST, UGC, URPS, and grant sanction for this work around 90 lakhs approximately. So I wish him a bright future. Thank you very much. Thank you, sir.
Our speaker to start his presentation, Dr. Nanda Kishore Karde.
Very good morning to one and all present here. First of all, I am very much thankful to the organizing committee, the principal of the college, head of the department, Professor Parate madam, Deshmukh madam, and my friend Praveen Bodke for giving a nice introduction. So thank you once again for giving me this opportunity to deliver a favorite talk on applications of hypervalent iodine reagents in organic synthesis. I have joined Nagpur University in the year 2009, and from 2009 to 2020, almost 10 years, I have worked on this particular field. And here I would like to share some of the results on applications of hypervalent iodine reagents in organic synthesis. Now, our university is literally very old university. It is almost 57 years old department. And in this department right now, recently we have assembled some instrumentation facility, and among them we are having FTIR. We have installed it in the year 2011, and recently we are having a important equipment, that is LCMS MS 8040 triple quadruple shimmered zoomic. So with these facilities and the culture around us, I have tried to develop some methodologies using hypervalent iodine reagents. So first of all, I will talk about what are the hypervalent iodine reagents. Then I have performed, with the help of hypervalent iodine reagents, some cross coupling reactions involving CO bond formations, nitrogen oxygen bond formations. In some cases, I have also made oxidations of tertiary alcohols. Then derivatizations of imidazopyrimidine heterocycles I have done. I have also done some derivatizations of butynylic compounds with the help of hypervalent iodine reagents. Now, before explaining all these results, I would like to explain you what is this hypervalent iodine reagents. Now, if you consider this chart, is it visible to everybody? Please. Is it visible to everybody? Yes. So if you look at this chart, you will find that they are the derivatives of the iodobenzene. Some of them are trivalent iodine reagents, some of them are pentavalent iodine reagents. So trivalent iodine reagents and the pentavalent iodine reagents are called as hypervalent iodine reagents. Now in this case, one thing is common in all the cases, they are the derivatives of iodobenzene. So aryl group is compulsory there, and apart from the iodobenzene, now different ligands are attached to this iodine. Some of them are fluorine, chlorine, here is a oxygen, here is a hydroxyl, here is a OTS group. Then in some cases, the carbon group is also attached. Now depending upon the nature of the ligands attached to these iodines, these iodine reagents perform a very novel organic chemistry, and that's why recently there is a tremendous interest of organic community in the applications of these reagents in modern organic synthesis. Now, if we look at the scenario here, there are certain dedicated groups throughout the world. Professor Jhadkin, Professor Thomas Worth, Professor Ishihara, Professor Robert Moriarty, Professor this Okai, and the lady here is Professor Berit Olofsson. So while doing any kind of work, I used to visit their homepage very regularly. They are front runners in the field of this hypervalent iodine reagents. So inspired by this work carried out by these researchers, I have done some organic chemistry at my workplace that I would like to share first of all here. Now this is a very demanding transformation, cross dehydrogenative coupling. It is called as a CDC. For formations of any bond, if you remove these two hydrogens, then it is definitely a very important kind of improvement from green chemistry point of view. Removal of these two hydrogen is indeed very difficult task, and that's why recently there are a lot of publications on a topic called as cross dehydrogenative coupling. With the help of cross dehydrogenative coupling, you can maintain high atom economy. Then reductions in the number of steps of the organic synthesis. It means that if you want to form a bond between A and B, then sometimes you have to functionalize either AH or BH. For example, let us make here a halide and then you perform a reactions. So pre-functionalization is avoided, and that's why you can reduce the number of steps. Then you can have minimizations of the byproducts. These are the important merits associated with the cross dehydrogenative coupling, and inspired by this, I have carried out one synthesis here, and here the cross dehydrogenative coupling leading to formations of CO bond is reported. Now if we go through the literature reference, we come across the literature reference. The first literature reference is copper acetate, and the reaction is reflux at 130 degrees centigrade. The paper is published in very high impact factor journal IUK. Then we came across a ISC Bangalore paper where they have used stoichiometric silver oxide, and the paper is published again in Chemical Communications 140. And another paper is again a copper based. Now from these three literature, it is very clear that to accomplish a carbon oxygen dehydrogenative cross coupling, we require a transition metal and we require a very high temperature, and therefore there is a need for the improvement. and indeed we were successful to do this kind of the transformation under very ordinary conditions, exceptionally mild conditions. Just at room temperature, if you add diacetoxyiodobenzene here, we are getting cross dehydrogenative cross coupling here. And here see this hydrogen is removed, and here this carbon hydrogen is also removed. These two hydrogens are removed. It leads to the formations of carbon oxygen bond, and it is called as a cross dehydrogenative coupling. In other words, we have made a functionalizations of sp3 carbon atom here. If you want to make a functionalizations of sp3 carbon atom, it is necessary that this carbon atom should be pre-functionalized in the form of halogen, for example. But here, without any pre-functionalization, it is possible to do this kind of the chemistry. And these are the features. It is indeed a metal-free synthesis, mild conditions, and the mechanism that we propose is very attractive. Now, why metal-free reactions are encouraged nowadays in modern organic chemistry? See, in pharmaceutical drug synthesis, if you suppose use metal somewhere in one of the steps, and if some ppb level kind of the impurity is carried out, it may affect the profile of the drug. Therefore, there is a demand for metal-free synthesis, and hypervalent iodine reagents are considered as metal-free reactions conditions. So here, with the help of a trivalent iodine reagents called as diacetoxyiodobenzene, we have performed here dehydrogenative cross coupling reaction, and this paper was published in the year 2016 in Tetrahedron Letters. Now, to get this kind of the work, first of all, we have to prepare the starting material. Starting material we have to prepare, and it is, you can take this kind of the chemistry even in your MSc projects also. Beta-naphthol, benzaldehyde and piperidine or pyrrolidine or morpholine. Okay, if you condense these two in ethanol for 16 to 24 hours without any chromatographic purification, just by recrystallizations, you can get a starting material. This particular reaction is called as a Bettys reaction, and the substrate is easily accessible from these three component reactions of beta-naphthol, aldehyde and piperidine. So we have prepared a range of starting material, and after preparing the starting material from Bettys reaction, we perform here a dehydrogenative cross coupling, and my student has prepared 1 dozen molecule. Actually, I insisted him to go for more examples, in fact, but again there are certain restrictions, certain limitations. Everybody is having limited capacity. We were expecting a very good publications in SCS and all that, but since the library here we have prepared is literally a small library, so all these 12 molecules we have prepared, and you see here somewhere we have used 5-membered ring pyrrolidine, here we have used piperidine molecule, and in some cases we have used morpholine also. And in this way we have got here a functionalizations of sp3 carbon atom, and we have prepared this range of molecules. Now let us come to the mechanism. While proposing any organic reactions, we should have some logic behind that, and here we propose it. And when we propose this mechanism in the manuscript, at that time we got really lot of appreciation from the reviewers, because compared to the copper catalysis, compared to the silver catalysis, this mechanism is very attractive, and perhaps it was the strength of our manuscript, strength of our work we have carried out. So what happens here, I would like to explain you. Hypervalent iodine reagents are working like transition metals. Transition metals work like oxidative addition, reductive elimination, ligand exchange, ligand association, ligand dissociation. The same thing happens at the coordination sphere of iodine without any concomitant toxicity, and that's why there is a lot of demand of hypervalent iodine reagents in modern organic synthesis. So ligand exchange, ligand association, ligand dissociation, oxidative addition, reductive elimination. If you know the basic coordination chemistry, then you can enjoy this mechanism very well. So at everything occurs at the coordination sphere of iodine. This acetoxy is a very labile ligand, OH is another ligand, so ligand exchange occurs. Nitrogen is again acting as a ligand, ligand exchange occurs here, and we get here N+, and this hydrogen is now becoming more acidic compared to the ordinary, compared to the starting material. So it will abstract a proton here, and we will get here a iminium ion. Okay, at the end iodobenzene goes away. It is called as a reductive eliminations, and we get here a iminium ion, and that iminium ion is subsequently trapped by the this anion, and we get this cyclization. So we have proposed this mechanism of these reactions, we have characterized all the products, and overall it was the strength of our manuscript. So in conclusion, what I want to tell you, I have functionalized here sp3 carbon atom, direct functionalizations of sp3 carbon atom. The methodology is called as a cross dehydrogenative coupling, and here hypervalent iodine regions, trivalent iodine regions we have carried out, and the conditions are exceptionally mild, and moreover it is a transition metal free protocol. So because of that, this paper was published in Tetraedon later. Now I would like to share the NMR of this molecule. See, we always do the vigorous analysis. In organic chemistry, if you are not having a NMR, if you are not having a mass, you cannot claim that this is firm or that is firm. Okay, so we have attached all these NMRs as a supporting informations in all the papers. And if you look at the NMR, here see this hydrogen, this hydrogen is a asymmetric center, and this HA and HB, these two becomes a distereotopic protons, and these two becomes non-equivalent. They will couple with each other, they will couple with this, they will couple with this, and indeed we got here two different signals for these distereotopic protons. This proton and these two protons are obtained as a singlet here. So it is consistent with what we have proposed. Then this is a C13 NMR spectrum of this compound, and it is again inconsistent with what we have proposed here. And this is the HRMS, high resolution mass spectrometer. Since only two hydrogens are lost, we have to be very particular. The exact mass, theoretical mass is 302.1519, and what we observed here 302.1549. So it was close in agreement with what we have proposed there. And this paper was published in a journal Tetraedon later. My student particularly, this Amit Kalwande, then Nitin, all of them worked very hard to do this kind of the transformations. Almost it has taken 6 months to complete the task. Okay, so these were the comments of the reviewer, and reviewer's comments I am just sharing with you actually, and as usual you will find that they are recommending it. The first reviewer say that it is a novel use. It is a novel use, the term used by the reviewer, and whenever we get such kind of the things, we get the encouragement to work at a place such as Nagpur University. Okay, so this is the first problem that I have shared with you. I will share 2 to 3 problems only, and then I will stop here. And near about more than 10 results I am having in this PowerPoint presentations, but instead of 10 I will share only 3 or 4 as the organizers suggest me here. Now second transformation that I would like to discuss with you again is a dehydrogenative cross coupling. Here hydrogen and hydrogen I have removed, but this time the bond between a nitrogen and oxygen I have developed. The formations of bond between a heteroatom and heteroatom is always difficult. Nitrogen and oxygen, they are having a comparable electronegativity, and forming the bond between a nitrogen and between a two heteroatom is generally a difficult task. If you want to form a bond between a carbon and heteroatom, it is always easy, but here the formations of bond between a heteroatom and heteroatom is indeed difficult, and we have accomplished this, and the paper was published in the journal Synthesis in 2014. Now this is a paper here. Now from where the idea is generated, I always like to share this kind of the things with the audience. Ideas kahan se aati hai, from where the ideas come. As usual here, see, this is in the previous BT reaction I have done a beta-naphthol, benzaldehyde, and then I have taken cyclic amines. Now instead of cyclic amine, this time I have taken urea. Okay, so this can be prepared in good purity by 3-component condensation of beta-naphthol, aromatic aldehyde and urea, and we get this phenolic substrate. Now phenols are very fertile functional group as far as its reactions with the hypervalent iodine reagents are there, and this is the literature report. Literature report suggests that phenols undergo facile oxidation using hypervalent iodine reagents, and they can form here spiro type of the compounds. Spiro compounds, you might have learned the spirans here in stereochemistry. They are the chiral molecules. So getting a spiro compounds is a well-known fact in the literature. Here also we thought that it's a phenolic compound and we may get a spiro compound. We were expecting this spiro compound, and according to the mechanism what we have proposed here, but actually this is not the case. This is not the case. We never got a spiro compound, and we got here a oxygen nitrogen bond formation. And when we went through the literature, we got one paper where oxime was involved. Oxime was involved, and this oxime was not, there was no nitrogen oxygen bond formation, rather this oxygen was participating on the another aromatic ring. The paper is from Organic Letter. Second is in a synthetic communication we came across this paper, and we thought that our substrate is different, our chemistry is relatively improved chemistry here, and therefore we undertook this particular study. Okay, now if you want to prepare such kind of the things, that's a nitrogen oxygen bond, there are three main strategies available in the literature. One is a 1,3 dipolar cycloaddition reactions of benzene with the nitrile oxide. Second one is here a nucleophilic substitution. Here there should be a presence of some electron withdrawing group, then and only then the oxygen can be introduced here, and there should be a presence of leaving group here with the appropriate stereochemistry of the imine. So this is only methodologies available to form the benz isoxazole, and therefore I thought that let us go for this. Okay, so we prepared range of molecules by condensations of beta naphthol, aldehyde and urea in presence of para-toluene sulfonic acid, and then we subjected a dehydrogenative cross coupling oxygen and nitrogen, and we have again here prepared 12 molecules. Generally, if you want a good paper, lot of molecules has to be synthesized, and whenever there is a synthesis, it should be again supported by data. And since there are lot of limitations, just to record one NMR, PMR and C13, it costs nowadays 1000 rupees. So doing this one chemistry, one problem for 50 to 60 example, 60 to 70,000 rupees are only required for NMR. So even though there is a lot of desire for excellence, sometimes that becomes a limitations and we cannot do anything. So here only 12 molecules we have prepared, tried to keep library here by variations of aldehyde as well as beta naphthol component, but very little molecules we have prepared. With these 12 molecules we published the paper. I will again tell you the story about that as the discussion progresses. So once again I would like to share the hypothesis, mechanism, the logic behind defining the problem. So everything occurs on the coordination sphere of iodine. Iodine undergoes ligand association, ligand dissociation, reductive elimination, everything occurs here. So OH group here acting as a ligand, it undergoes ligand exchange, we get removal of one OAC group, then the second nitrogen comes, and in this way the two reacting ligands, nitrogen and oxygen, are assembled on the coordination sphere of iodine, and there is a propensity of iodobenzene for reductive eliminations. So at the end iodobenzene goes away and we get a nitrogen oxygen bond. Very interestingly here the carbon nitrogen bond also cleaves, and that is the only thing we have proposed here. So when we recorded the mass, we observed that this amide linkage is also lost here, and we get here benzo-fused benz isoxazole. Now this is the NMR spectrum of this compound. It's a very clean NMR. This NMR is equivalent to the number of protons what are available in the starting material. This is a C13 NMR, and this is high resolution mass spectrum. I would like to tell you this paper was twice sent by editor back. They were requiring HRMS compulsorily, and of every molecule. So again, after submitting the thesis, my student went back to his home, and again I called her and she performed again this HRMS analysis just to fulfill the requirement of a journal. And here the calculated is 260.1070, and the found is 260.1067. so that was the accuracy level carried out by my students. This is a LCMS spectrum. At that time we were not having LCMS in my laboratory, and at that time I felt that apne lab mein LCMS chahiye, and then we proposed the this proposal to the UGC, and we got now this LCMS. And again, getting LCMS is not just sufficient, it's maintenance and then routine work carrying out, documentation. Nowadays lot of documentation is increased, and we are having this facility. If in the audience anybody is doing some good organic chemistry, please come to us for any kind of the analysis for LCMS here. And at the end, this is a conclusion. In conclusion, let me tell you, it is a new methodology we have developed. It is not a reported anywhere, this kind of the chemistry. It's a new kind of the transformation. Then it's a dehydrogenative cross coupling. 2 hydrogens are removed, and that too under the mild conditions without using transition metal diacetoxyhydrobenzene. And it was a new observation, because phenol generally gives you quinone type of the moiety, it gives a spiro type of the compound, but here we got this heterocyclic compound. And that's why, since it's a new chemistry, it was accepted by the reviewer here, and you will find that lot of suggestions about the C13 NMR coupling constant. Okay, and just everywhere they are asking about the data corrections. Data is very important. However, an elemental analysis or HRMS of all new compounds are missing in the experimental part. They are missing, and therefore when it's a missing, you cannot, that they want it at all. And we again the perform analysis, and it was finally there was a happy end as far as this problem is concerned. Now third transformation I will discuss, and then I will stop. This is the last transformation that I will discuss here, and this is my recent paper. I would like to say recent because after that I couldn't get a good paper, and that was published in European Journal of Organic Chemistry. Now this is a heterocycle. This heterocycle is called as imidazopyridines, and this imidazopyridine, there are a lot of publications on imidazopyridine recently in the literature, and these publications are related to the functionalizations of this carbon atom. This is C3 carbon atom, and therefore we were interested to functionalize it, and I will tell you here how this problem was proposed. So if we do the literature for doing any kind of organic chemistry, for any kind of literature, any kind of research, you should have a sound literature. In this literature survey, you will realize that this carbon atom is functionalized with the help of lot of substituents. Here is a carbon, here is a carbon, here is a sulfur, here is a carbon, here is a sulfur, here is a phosphorus, here is a sulfur, and here is a fluorine. So what I want to tell you, they tried to incorporate lot of functional group at this position, and we came to know that nitrogen is unexplored. Nitrogen is unexplored. Therefore we decided to functionalize this molecule with the help of nitrogen nucleophile using again hypervalent iodine chemistry. So what was the idea? What was the idea? Idea was that this molecule will undergo azidation, and you will get an N3 here, and this azidation, azide will undergo 1,3 dipolar cycloaddition reaction, and that is called as a click chemistry, and we may get a drug like substrate, a drug like molecule. Okay, so it was a hypothesis, it was a plan. Okay, but when we perform the reaction, we couldn't get azidation here, and since we couldn't get azidation, we cannot do the subsequent chemistry. So NMR came to our laboratory. For 3 to 4 months we couldn't interpret the product, we couldn't interpret the structure of the product, because PMR is there, C13 is there, and at that time mass facility we were not having very much at our hand. But again, by looking at all this all this spectral data, we reached to the conclusion that we got here iminonitrile compound. It is a imine and it's a iminonitrile, and then we undertook the literature survey of iminonitrile, and we came to know that iminonitrile is a versatile intermediate in organic synthesis. Iminonitrile is a precursor for optically active amino acids. You can prepare range of amino acids from iminonitrile. Then you can have here, it is used as a cyanation reagent. Cyanations of arin is also reported. It undergoes some cycloaddition reactions, and it encourages us to say that iminonitrile is a versatile intermediate in organic synthesis. And since it's a versatile, we have got accidentally in our transformation. Then we decided to undertook this study. Now again, if you look at the literature survey of aminonitrile synthesis, they are using generally the potassium cyanide. They are using a cyanide supported umberlite. Again here sodium cyanide is used, isocyanide is used, trimethylsilate cyanide is used. So generally for the preparations of aminonitrile, cyanide, potassium cyanide or that cyanide derivative is a source, and everybody knows that cyanide is deadly toxic. So because of that, we decided to we were very happy to know that we have prepared this aminonitrile without the use of cyanide here. So these were the sodium cyanide, copper cyanide, bromogen cyanide, mercury cyanide, trimethyl cyanide. What I want to say, cyanide is generally there, but here we have developed a methodology without again cyanide. Okay, so this is now 22 examples. We have now upgraded ourselves. In previous cases, 1 dozen molecule we have prepared. Now here we prepared 22 examples because the chemistry involved was literally very rich. It was a cyanide free chemistry. We have prepared a cyano compound without using potassium cyanide anywhere. And here again these molecules, this starting material, this we have to prepare by reactions of 2-aminopyridine with the phenacyl bromide. So 22 examples here I have shown successful. 22 starting materials we have to prepare also, and 22 plus 22 means it's a 44 reactions. These 44 reactions are only the successful. Again more than 20 to 25 reactions were failed as far as the purification is concerned. So near about a set of 100 reactions we have prepared to investigate this particular problem. And why we have increased this 22 examples? Because our expectations very high from this particular paper. We decided to communicate this paper to the Journal of Organic Chemistry, and out of 3 reviewers, 2 reviewers accepted it, 1 reviewer didn't accept it, and the main editor rejected it, and therefore we finished with the European Journal of Organic Chemistry. That story I will tell you later on. Again, this is a clean NMR of this compound, and I request to all of you to go to the supporting informations of all my manuscripts, and you can enjoy this kind of the exercise because you are having in practicals structural elucidations of NMR. So this actual NMR can be given to the students for structural analysis, how to calculate the coupling constant from actual NMR, then number of protons calculations. It can be taken as a good exercise to the student. This is a C13 NMR. In C13 NMR, this carbon atom is characteristic appearing around 110. Okay, this is very important observations here. 110 this carbon atom is observed. And again the HRMS, 22 examples we have prepared and 22 HRMS we have reported here. Okay, the theoretical value is 238.0970 and the observed value is 238.0975 here as far as this compound is concerned. Okay, again you will find lot of NMR in the presentations. And now here the logic. Now here the logic here, how this transformation works here. And when we propose this mechanism, you know, sometimes there is really a fear in the mind whether this is correct or wrong. But when it goes to the reviewer, very expert reviewer, and if you don't get any kind of negative comments, then indeed there is a lot of encouragement to do these works at Nagpur University. So what happens here, again this iodine is electrophilic in nature and it attacks, it gets connected here. Then reductive eliminations occur, and finally we propose here azide as an intermediate. And we know that azides are thermally unstable. Azides undergo eliminations of the nitrogen molecule, N2 molecule, and we will get here a nitrene. This nitrene will undergo cycloaddition reaction and we will get a here aziridine type of the intermediate, and this aziridine undergo rearrangement and we get a aminonitrile. So a very valid mechanism we have proposed here, and there was no any wrong comment from the reviewer as far as this is concerned. So here I would like to suggest that we have developed a cyanide free protocol for the synthesis of aminonitrile compound, which is a versatile intermediate. You can prepare lot of chiral amino acids from aminonitrile. It's a cyanide free protocol, it's a metal free protocol, conditions are mild, and it is a transition method free protocol, and that's why this work is having certain merits on its own. And finally, we couldn't get a paper in Journal of Organic Chemistry, but we got a paper in relatively good journal, European Journal of Organic Chemistry. Okay, so these three transformations I have discussed here. There are so many things to share with you, and if you want, you can search my papers from Google anytime, and after I would like to just share here certain things. After joining Nagpur University, I have published total 18 publications, and out of 18 publications, dozens of publications are very satisfying. They are relatively in a good journals. Then this is my team, my students. Getting a team is also very important. Nowadays, I do not have that much active team in my class, in my laboratory. These students work day and night. Okay, and I was also with them day and night, and all of them are having job everywhere. These two students are in the industries. They are at very high positions, and remaining students are assistant professors somewhere. All my research scholars are employed right now with they are having some job somewhere or other way. That is very satisfying kind of experience. And this is my laboratory of Nanded University. Actually, the hypervalent iodine comes from Nanded. Okay, and it continued in a full-fledged manner at Nagpur University. And this is a place at Nagpur University. And this is all my students. One student is in a Glenmark Pharmaceuticals. Another student in agrochemical industry nearby in Delhi. Then one student is in MQR Pharmaceuticals Pune. And all of them are assistant professors, and one student is searching for the job. Okay, and I'm very blessed with the I could do this kind of the work, otherwise it was not possible to do this entire analysis. Okay, once again I would like to share these two photographs, and I request to all the audience, if you want this NMR, this mass facility as well as FTR facility, that is given on our website. Feel free to ask for me any kind of the help, not only for analysis but for even any organic chemistry related research. If you are undertaking, I am always ready to help you by all means. Okay, so here I would like to stop my presentation, and I thank you very much for your attention, and questions and comments are welcome. Over to you, madam.
Hello.
Ha, madam.
The question. Somebody has any question? Can you ask?
Please ask the questions related to this work or related to organic chemistry, related to the analysis. Any questions?
Yes, Alpesh, you may ask.
If anybody having any question, ask kindly to sir. So don't have a problem.
Participants.
Any question? No, there is no question to the students.
As usual.
Hello, sir.
Yes.
So the iodine has a its atomic number was of 53. The general electronic configuration is 2, 8, and 18, 7. So there are the two pair electrons, and I think the valence electron was the 7. So the I think that research was a one the I don't saw the structure
Yes.
pair
Yes.
and pair.
Yes.
So
I got your
I
question.
confused.
So it is, the basic bonding chemistry question. It is a hypervalent bond. Hypervalent means more than 8 electrons are in the coordination sphere of the iodine. So in trivalent iodine there are 10 electrons. In a pentavalent iodine there are 12 electrons. Just like your Des-Martin per iodine. Des-Martin per iodine is having total 12 electrons and it is having 10 electrons, trivalent iodine. So hypervalent iodine means 3 center 4 electron bond. Hypervalent iodine means it's a 3 center 4 electron bond. Got it?
Yes, sir.
It's a 3 center 4 electron bond. Out of four, 2 are provided by iodine, and 1 electron is provided by the ligand.
Thank you, sir.
Okay, fine. Next.
Anybody? Alpesh?
सर हेलो
बोलो।
हाँ सर, हम लोग किसी भी तरीके से रिसर्च की स्टार्टिंग कैसे कर सकते हैं?
You are a MSc student?
Yes, sir.
My suggestion is that you qualify your CSIR exam first of all, and as soon as you qualify your CSIR exam, you will get admission in any national institutes where these facilities are on fingertips. Okay, and as soon as you join there, you can start it. Okay, so first of all, you textbook chemistry, you strengthen it, and because see, for in research you require thinking, and thinking means you should have some background. Background is very important. You must be in position to read the literature. So my suggestion right now to use that, you read some standard textbooks of organic chemistry very seriously, qualify your CSIR exam, automatically you will be in that direction.
Okay, sir. Thank you.
Okay.
Anybody else? Okay, thank you very much, Dr. Sir.
Okay, thank you.
Thank you, sir.
Thank you very much.
Thank you, sir, for your effective and informative presentation. It will definitely benefit to our new researchers in this organic synthesis field and cycles. Really, all the methods are very novel, especially the cyanide-free reaction. Definitely will enhance the ideas of the new researchers. Thank you, sir.
Madam. Thank you, madam. Thank you.
Next.
So, now before moving to our next session, I would like to invite Dr. Jaya Pansod to introduce our guest lecturer, Dr. Tekade, sir.
Hello and welcome to all. It's my honor to introduce Dr. Pradeep Tekade, sir. Presently, he is working as Associate Professor and Head Department of Chemistry, Bajaj College of Science, Wardha, since last 18 years. He also qualified NET, SET and GATE exam. He has published more than 50 research articles in various research journals. He completed 3 major research products funded by UGC. He published more than 14 books, out of which 7 are internationally published. He also guided more than 30 PG students for research project dissertation. He awarded by Vidya Ratna Award by INSA and also Vidya Bhushan Award. He also worked as a resource person, jury member, and observer for JEE, NEET, and NET exam. So I wish him for a very bright future. Thank you.
Now I request Dr. Pradeep Tekade sir to start the presentation.
Okay, thank you, madam. Thank you, sir. Am I audible?
Yes, thank you very much.
Thank you, sir.
Okay, sir. First of all, I am very much thankful to my teachers for giving me this an opportunity to talk with especially with the MSc students. I am grateful to respected principal of Vidyavarti Mahavidyalaya Amravati, then Dr. Parate madam, HOD Department of Chemistry, Dr. Maurya madam, my favorite teachers, Dr. Bodke sir, Dr. Deshmukh madam, Dr. Enan Karde sir, our supporter and mentor, who is ideal researcher for us, all the organizing committee members, all the faculties who are going to attend this webinar, and my dear students, namaskar. Indeed, it is a thing of I think somebody has unmute the audio who is disturbing. Okay, thank you. Indeed, it is a thing of pride that my teachers give me this opportunity to interact. Am I audible?
Yes.
Okay. Yes, it is a thing of pride that my teachers give me an opportunity to interact with MSc students and researchers, research scholars and faculties. For today's lecture, Bodke sir has suggested me a topic, plagiarism and bibliographic citations for this webinar. And pertaining to this, I have prepared this presentation, small presentation of 45 or 50 minutes duration, especially for MSc student, and hope it will be applicable, it will be helpful to some research students working in this field also. Yeah. Okay, so topic for the presentation is plagiarism and citation. And after that, we will discuss about the MS Word 2007 onwards app or Microsoft Word, that how it is useful for our research for referencing section that we will discuss in brief. So these are the contents of topic. I have divided the topic in three parts. First, we will discuss in short about the plagiarism, then citations, and then we will discuss about the, and if the time permits us, we will see the hands-on training on MS Word for giving how to give the bibliographic citation and about the reference section, how to prepare it by using MS Word. First of all, plagiarism. In the last semester of masters in all universities, there is an incorporation of a project work in lieu of one practical paper in the curriculum. It has been included in the curriculum to provide the opportunity to the students to show that the students have gained the necessary skills and knowledge in order to organize and to perform the research project. It is expected from the student that the student should do good piece of work, which is feasible as per the facilities available with you. Whatever may be the work, which is feasible as per the facilities which are available in your laboratories. So that is the expectation. But for sometimes, what happens, students are reluctant to do the research work. They want a ready-made one. And so due to overloading of academic work as well as some administrative work, the teachers are also busy, and hence it is not possible for us also, for the mentors, to monitor the quality of the research project. And due to this, the quality of project get down. Secondly, the publication of research paper manuscript in good journal means the publication of not only journal or any intellectual property, publication of intellectual property is an important aspect of the research. When mentor asks to ask the student to write the paper and publish it in good journal, students, what do they? Students copy and paste the stuff from the internet. I am not talking about all the students, some students. Number of students are good, but some students do these practices. They copy paste the stuff from internet, that is Google Baba, everything is available there, and submit it to the journal. And that is wrong. Publication in the reputed journal of good quality, that is index in UGC care list or peer-reviewed journal, is a mandatory nowadays. The publisher like, Wiley, Elsewhere, Springer, Taylor and Francis, ACS, they are considered as a reputed publishers. There are some hereditary journals are also which publish the paper by taking the money. Therefore, while selecting the journal for publication, the first step that you have to see that it should be indexed in Scopus or Web of Science databases. If the paper is there in Scopus or Web of Science databases, if the journal is there, then definitely it will be in UGC care list, and that will have the good quality. I think so. Now, while writing the manuscript, there are various heads. There are various parameters in the manuscript, like abstract, introduction, keywords, experimental work, material and methods, results, conclusion, and last but not the least, that is references. While writing the manuscript, if you are doing copy and paste, then it is considered as a theft. If you are doing the copy and paste from internet or from other work, it is considered as a theft. Yes, theft. That is plagiarism. That is the topic for discussion today. As I told you that then we will also discuss about the neglect. And let me tell you that this is a neglected reference section, is a neglected part. Unfortunately, it is a neglected part of the manuscript from the author side. So we will discuss in short about how to manage our references by using our simple MS Word 2007 onward version. Okay. Let's come again what I have given here, that the utilization of other ideas, writings, that is not common. That is not common knowledge. That is open. That is not open education resources. If you are utilizing this without giving the citation, that is treated as a plagiarism. Secondly, the presenting the works of others' original work without giving the credit, intentionally or unintentionally. Copying complete or part of the other's work is without giving the citation is considered as a plagiarism. Okay. Now, how to avoid the plagiarism? Plagiarism can be avoided. Okay, before that, let me tell you that this image you can see here, copy paste image is there. That copy paste image as well as this image on this slide, actually I have taken it from the internet. So I must give the source of that image. But deliberately I have not given that source, that source here. So it is a plagiarism, remember. Whatever you have taken from the material, whatever the material you have taken from the literature survey, from internet or book or whatever it may be, that is considered as a plagiarism. Okay. Now, how to avoid the plagiarism? By giving a credit wherever we use a quotation from others' verbal or written words. Means if you are giving a credit, if you are giving the citation to the quotation given by other verbal or written word, then it is we can avoid the plagiarism. Then plagiarism can be avoided by rewording of others' oral or written work, written terminology. You can remold the sentences, then plagiarism can be avoided. And then plagiarism can be avoided by giving credit whenever you use others' views or ideas or hypotheses. In short, in brief, in one sentence I can say, by giving the credit to the author, original author, you can avoid the plagiarism. That is a simple thing. These are the plagiarism detection tools which are available on free. Some of them are free of cost, some of them are paid. And is this slide is sir, is this slide plagiarism detection tool? Yes, it is. Yes, it is there. Okay, so this is the list of some plagiarism detection tools which are available free of cost. Some are online plagiarism detection tools and some are paid. Okay, so you can partially detect the plagiarism. In our university, Urkund is there, by which we can determine, analyze the plagiarism, contains how much percentage of material is plagiarized there. So by using some this software free of cost which are available, we can minimize the plagiarized material. Okay. Now let's move on the citation. We have discussed about the plagiarism. We have discussed about the how can we avoid the plagiarism. Now let us see the citation. Okay. Citations are needed when we get information by interviewing somebody. Citations are needed when we duplicate the exact words or work of others. Already in plagiarism, I have told you that when the citations are needed. Now, when the citations are not needed, the citations are not needed when you write from your own work. The old work is your own observations, your own ideas, your own theories. In that case, citation is not needed. Citation is not needed when the common knowledge, you are using the common knowledge which is universally accepted. And the shared, we can say it is a shared information which is universally accepted. Or we can say the open education resources. In that case, there is no need of citation. Citations not needed when you express your own investigational outcomes. It is obvious that as the investigational outcomes are your own and that are novel, there is no need of giving the citation in that case. Okay. Now, after that, as I told you, we are going to discuss the reference management system. 80%, as I told you, that the 80% of the manuscript, approximately 80% of the manuscript are rejected due to neglecting of these references, last section. Okay, because there is a cross-referencing, cross-checking of the references in the reputed publications. And that's why we should be very careful. We should be equally careful as that of our contents, that is material, methods, result. We should be equally careful while managing the references. These are the reference management programs which are available. Again, some of them are really available and some of them are paid. Generally, Zotero and Mendeley, these are the commonly used reference management programs. Others are also there. List is here. You can see this list. These are available on internet. But in today's lecture, we are going to discuss the use of MS Word for giving citation and references, that is bibliographic section. Everybody is convenient, everybody is used to with the MS Word. And by using that MS Word, we can give the citation and bibliographic indexing. Let us see how to do this. In next 5 to 6 slides, I will show you the screenshot that I have taken. And after that, we will have a hands-on training if it is possible, if the time permits us. Otherwise, it is easy to handle. No issue is there. Okay, see, MS Word is a great tool for citing sources, creating bibliography, and managing sources. MS Word 2007 onward version has this facility. The first step to create a reference list and citation is to choose the appropriate publishing style. If you going to publish the paper, the journal have some guidelines. First, you have to read that guidelines. In the guidelines, they have the PDFs in detail that what should be the font, what should be the hierarchy of this, all these result, discussion, conclusion, what should part be there, what should be the resolution image, all these and this. And if your work is very good, but if you are not obeying the rules of journal, then even the work is good, the paper will not be published in the journal. That is the thing. So you have to give the equal weightage to this part also while submitting while people preparing the paper. Read the guidelines very carefully. Now, as I told you that the first step to create a reference list and citation is to choose the appropriate publishing style. Every journal has its own publishing style, like APA, MLA, etc. I will go to that point in detail. At this moment, just remember that the publishing style is different for different publisher, and you have to follow that. I have put here two papers. This is paper number 1, and this is paper number 2. These are my papers, and I am going to read one sentence from the introduction. I think it is visible to all of you. See, in the introduction, controlling air quality and water pollutant is a big challenge for environmental research. The first sentence, controlling air quality and water pollutant is a big challenge for environmental research. And after that, in square bracket, number 1 is written. In square bracket, number 1 is written, that is a citation. Means this sentence has been taken from somebody's work. Now see this second paper, which is published in another journal, RSC journal. See introduction. In recent years, yes, I am going to read this one. A new method, can you see my cursor? A new method has been developed to obtain more efficient compounds in short reaction time period. And see here 1,2. It is written as a superscript. It is written as a superscript. In the previous slide, it is written in square bracket. And here, I am talking in detail just for the MSc, considering the MSc student as their first step. And here 1 and 2 are the superscript. But I want to convince you here that the different style is there, different citation style is there. Okay, so we have to take care of that. See, now from the same paper, I have given here the reference list. This is the reference list for the paper number 1, and this is the reference list for the paper number 2. And in the reference list, I am going to read the first reference. You can see here, it is a Gupte, PR, semicolon, then Pandit, AB, then name of the journal in italic, in bracket, there is a press name, and then there is a year in bold, then issue number, then page number. Okay. Now see the style of the second paper for the referencing. Here it is, see the second reference. V.K. Ahluwalia and R. Agrawal. This is the name of author. Then paper name, and then Narosa Publishing, it is the publisher. And finally 2007, it is the year. But I want to convince you here that in two different papers, the referencing section is also different. Okay. And as per the requirement of that journal, you must publish, you must write the manuscript, otherwise it will be rejected. Okay. Now, finally, we are going to discuss that how to use the Word Microsoft 2007 onward version for this. Okay. Publishing, for publishing style, if first you have to click in the references tab, then click the style. See, this is the screenshot which I have taken here. In the references tab, there are various these sub tabs or icon: insert citation, manage sources, style, and bibliographic citation. I am repeating again: insert citation, manage sources, style, bibliographic citation. Now in the style, after clicking this drop down menu, you will get the different styles. For example, APA, Chicago, this GB 7714, this one, then MLA 622, Turabian. These are the different styles which are recommended by the journal. And first thing, while managing the references, that you have to select the appropriate style. So for this moment, I have selected here APA as a referencing style. My request to the students, MSc students especially, that after this workshop, after this webinar, you may do this work. You may try this work at your home, at your places. See, you have to go to references, then you have to click on the style. I have selected here APA style. You may select Chicago, etc., etc. Okay. You have to choose the proper style. Okay. After choosing the proper style, then the second part is citations. To insert a citation in the text of document, as I told you that you have to insert the citation of the author in the text of document. It may be in the introduction, or it may be in the material method, or it may be in the result. Okay, for that again you have to go via the same way. See this screenshot in the bottom in the reference section. You have to click on the insert citation. You have to click on the insert citation. After clicking the insert citation, you will get these 3 points: add new source, 3 labels, add new source, you can see here, add new placeholder, and search libraries. And above that add new source, there is one reference which is already written there. Okay, because I have taken it from the help of Word, from the PDF which is given on the MS Word help menu. Okay, now see, I am repeating this one again. Let me tell you that first we have selected the publishing style, for example, APA, MLA, etc., whatever it may be. After that, we have we click on the insert citation. Now, insert citation, as you are the new user of this section, there will be 3 points only: add new source, add new placeholder, search library. Okay. Now, firstly, we will go to add new source. After clicking insert citation, now you have to click on the add new source. After clicking on the add new source, you will get such type of window, right? Now, there will be such type of information which you have to fill there. The first is type of source. The type of source in the drop down list, you can see book chapter, then journal article, patent, etc. type of source will be there. For this moment, I have selected here type of source, means the material from which you have taken the part or that reference. So type of source I have selected is a book. Then you have to insert here name of the author. You can edit this, you can add number of authors there. After that, title of the book, then year of the publication, then city, suppose New Delhi, Amravati, whatever it may be, and then the publisher, whatever may be, that is Pragati publication or whatever it may be. Then after clicking on the show all by bibliographic fields, some other fields are there also which are voluntary. This author, title, year, city and publisher are compulsory fields, and remaining are voluntary fields. Okay, so by filling the appropriate information there, you have to click on the OK. And this source, your reference will be created in the library. How to recall that saved source, that I will tell you in the later pages. Okay. Then in the same section, in the create source section, in the drop down list, you will see the book section. In the book section, again, there are different fields that you have to fill, and then you have to click on the OK. This is the important one. As a researcher are concerned, the journal article, you have to give generally the resource reference of journal article. In the create source section, in the type of source, journal article is there. You have to click on the journal article. You have to fill these bibliographic fields. Which font I have selected? APA. I have selected the APA, so that's why the bibliographic fields are available here for APA. If I have been selected MLA, then the bibliographic fields will be of MLA will be generated here. Okay, so this is very user friendly software. You can use it. Author, write the author name, title, journal name, year, pages. Show all bibliographic fields. After clicking on show all bibliographic fields, again some information you have to fill. That is the volume of the journal, issue of the journal, page numbers, etc., and then click on the OK button. And your article, your reference as well as citation will be saved. Okay. Similarly, you can add the conference proceeding in that section. Suppose I am giving a citation and reference of some conference proceeding. In that case, the bibliographic fields are author, title of the paper, then pages in the proceeding from page number 44 to 54, for example, like that. Year of the publication, then conference publication name, city in which the conference, at which the conference has been held, then the name of the publisher who publishes this proceeding. Again, here by clicking this drop-down box, show all bibliographic fields, you may add other information if you want, and then click on the OK. Similarly, one can give the source of patent also in the same way by giving the name of inventor, year of publication, and place, that is country, and the patent number. Okay. So up to this, what we have discussed so far, we have discussed that in the first step is using the publishing style, means APA, Chicago, etc., MLA. Then you have to click on the insert citation. After clicking insert citation, there will be three tabs: add new source, add new placeholder, search libraries. Then you can choose the book, book chapter, etc., journal article, conference proceeding, and likewise you can add the references in that section. Okay. So these are the two parts. Now the third part is placeholder. As I told you that here in this case, yes, here three in the drop down list. After clicking insert citation, add new source, add new placeholder, and search libraries are there. So let us see about the placeholder. What is the placeholder? Placeholder may be used when you do not have all the information available at that point, at that time, and by placeholder you may edit it in later on. I mean, suppose the incomplete information is available with me. Suppose the paper is there, but incomplete information is available. So right now, at that point, at that moment, you can fill that information, and the other information you can edit later on. To insert a placeholder, you have to click again, as I told you, in insert citation. In insert citation, there is a add new placeholder. See, this is add new placeholder, which is shown by a red arrow here. You have to click on the add new placeholder. After clicking on that, you can add the source. Generally, there is no need of placeholder. You can add at this beginning, just you use the add new source only. There is no need to use the placeholders, because add new source, again, you can edit it later on. You can manage that reference later on. Okay. Then next is the manage sources. In the same section, in the reference section, there is a manage sources. See which four sub icons are there: insert citation, manage sources, style, and bibliography. So manage sources. In the manage sources, you can manage it again. You can manage the sources which you have added from the new citations or from placeholder. You can edit them, you can copy them, you can delete them. Here you can also new source also. Okay. So this is the manage sources, to add, delete, and edit the sources. Okay, then finally, how to give the output? We have already inserted the input. Now we have to, we want the output of that. So bibliography, you have to click on the bibliography. Now, after clicking on the bibliography, you will get here 3 sections. One is bibliography, other is works cited, and third is insert bibliography. By clicking on this bibliography section, you will get the references. You will get the references which you have managed in the new site, in the new button. Okay, you get this as per the choice, means what as per the style, whether it is ML style or APA style or whatever it may be, as per the journal requirement. And work cited means as per the requirement of journal, you will get the citation in the body of the text where you want that. You have to click on that particular point, and you have to click the particular work which you have to cite there. So what is the benefit of using this software for managing our references at the early stages of our research? That it gives very accurate, precise referencing as well as citation work. Means what happens when you manually try to write the references? There will be some mistakes. Means dot, comma, then italic, then semicolon, colon. Sometimes bold is required. So in some style, there is a bold here in bold font. Like that, different formatting required there, and the mistake may be happen. Therefore, so as to avoid this, you recommend for the beginners to use this software. You will get a perfect bibliography as well as referencing section from this side. Okay, again, finally, I want to tell you about the insert footnote. Sometimes in the journal or in our thesis also, there is a need of to add the footnote. Now footnote 3 here, this is generally at the bottom of the page, and its font size is smaller than the running text. Okay, so yes, you have to go to this reference section, and there is an insert footnote option. Click on that insert footnote option and write down what you want, what is the required material there, and you will get the footnote of the particular size and research. Okay, so this is about the plagiarism in short, then citations. After that, I tried myself to discuss about the reference management system, particularly Word, and if the time permit, I can give the hands-on training. So, Bodke sir, please. Otherwise, I think it is okay. Sir. Okay.
Hello.
Yes.
Hello. Take care, sir.
Yes, sir. Yes, sir.
Thank you, Wantla.
Thank you, sir.
Hey.
Sir, if you permit me, I can take the live demonstration also, and otherwise it's okay from my side, sir.
चालेल ना, काय हरकत नाही. See, you can.
Okay, sir. Within 10 to 15 minutes, we will see that, and then I will. Okay, sir. Thank you. Thank you, sir. Sir, is it visible?
Yeah.
Yeah, okay, sir. Okay, so what I have told you in the PPT PowerPoint presentation. Now I am going to discuss in this word. MS Word. First, as I told you, go to the reference section and then click on the style. See, APA, Chicago, all this MLA, all these styles are there. I have selected APA style. Okay, after that, I have to go on insert citation. Let me increase the size. Yeah. Okay. Okay, so I have selected APA. Let us select the another style now. MLA style I have selected. Now insert site, add new source, add new placeholder, search libraries is there. I have click on okay, add new source. Now here in the create source, type of source is there. I can click on this book. I can click on this section, book section, journal article, article in periodical, conference proceeding, report. Sometimes we have to give the citation of the report also. Website, you can cite the website, document from website, electronic source, art, sound recording, performance, film, interview, patent, cases, miscellaneous. Okay, so suppose I want to give the reference of one journal article. So I will click on journal article here. Now author name. Suppose I am the author, Pradeep Tekade. So now title of the work. Suppose this is a title of the paper. Just for our convenience, organic compounds. Then journal name. Suppose the journal name. Rightly, Karde sir has told me about this. Told us about the tetrahedron, so I am going to write that in tetrahedron. Karde sir have very good publications in good journals. Year 2020. Suppose my page number in the journal is from 12 to 20. Okay, whatever it may be, 12 to 33. Now we are going to click on show all bibliographic field. After that, what the information I want to fill up here, city, that is not the mandatory field. Month, day, it is also not mandatory. Editor name, you can add the publisher name here if journal wants. Suppose Springer publisher, for example. Actually, it is a elsewhere publication. Okay, whatever it may be. Sorry, my okay, whatever it may be. Then volume, suppose the volume number 4, issue number 10 of that year. Then okay, then click on the OK. Then see, in MLA font, in the bibliographic citation, bibliographic text, only what is required in bracket, the surname of the author. If I choose APA, then what is the required for that journal? Surname of the author, comma, year of the publication in the bracket. If I am going to choose the Chicago style, same is there, but the font is different. In this, see, in this SISTO 2, organic compounds means the name of the paper, comma, then year, and in by bracket. Okay, so by using this, you can choose the proper style. By using the proper style, you can use the citation. Okay. Now, how to find out this in bibliography? Let us see. Click on the bibliography. In bibliography, in built-in section, bibliography and works cited are there. So I'm going to click on the bibliography. So see, this is the bibliography. For this particular SIST 02 font style, the bibliography should be like this. First, name of the title of the paper, then my name, means first surname followed by my name, after that issue number, and then publisher, sorry, it is mistake, then the comma, then year, then journal, then volume, then page number. This is the style. Okay, now I am going to in APA style. See, in APA, what is the requirement of the bibliography for the reference for the same paper? First, my name, Tekade, then comma, then abbreviation of my name. I have actually typed the Pradeep, but here it is P dot. After that, in bracket 2020 is there. 2020, that is the year of publication. Then full stop. Then this. So all the things as per the requirement. Let us see once again in the Chicago style. In Chicago style, the bibliography, the reference of this correct reference for this particular paper is like this. Okay. So what I have told you about the insert citation, style, bibliography. And finally, in short, let us see about the managed sources. This is the source which I have created. This is only one source which I have created. I can copy it, I can delete it, I can edit it, or I can add the new source from this source manager section also. Means you can do everything about the previously added resources, as well as you can add the new resources from this source manager section. Okay, so thank you, sir. Thank you. If the students have some question, they may ask.
Thank you, Dekar sir.
Thank you so much, sir.
Now topic is open for discussion. If anybody having any problem regarding that plagiarism and bibliography, so you can ask to sir. Especially MSc research project students. Unmute करा लागल सगळ्याला. See if anybody having question? अरे बाबा, आपको रिसर्च प्रोजेक्ट के बारे में कुछ पूछना है तो प्लेगरिज्म कैसे चेक करना है, सर से पूछ सकते हैं आप लोग अभी. MSc फाइनल ईयर स्टूडेंट्स है ना. चलो, as usual, no one is interested. So ideas are very clear.
Yes, sir.
एक मिनट.
हाँ
कुमारी नेहा.
हाँ बेटा पूछो.
नेहा.
Yes, please unmute yourself and ask the question.
तुमचं झालं की झालं ते सांगतात तुम्ही सर्टिफिकेटचं फीडबॅक
Okay, thank you very much, Tekade sir.
Thank you, sir.
Thank you, sir, for your nice presentation. This will help the researcher students. They should be aware of the plagiarism along with the subject knowledge. This knowledge is equally essential. Rather, it is the need of the day. And definitely all the participants are benefited, especially by your practical presentation. Thank you, sir, and all the best.
Thank you, madam. Thank you.
Now, we are in the last hour of our session, webinar, and I would like to invite Dr. V.H. Masan to propose vote of thanks. बोल सांगते मॅडम हे झालं.
A warm good afternoon to all the dignitaries present for the session, especially the resource persons and the attendees. So the job is to give thanks to each and everyone. Let me begin with Honorable Rao Sahib Shekhawat, the President of Vidya Bharati Vidya Bharati Shakshanik Mandal, for providing us the infrastructure and all the facilities to carry out this webinar. Sincere thanks to Honorable Dr. A.D. Chavan sir, the Secretary of Vidya Bharati Shakshanik Mandal, for encouraging us. Sincere thanks to Honorable Manjari Ji Shekhawat, the Chairperson of Vidya Bharati James, for motivating us to carry out such events regularly. Sincere thanks to Honorable Dr. P.S. Yankar Madam, the Principal of Vidya Bharati Mahavidyalaya, to allow us to carry out such successful events. Sincere thanks to Dr. R.M. Patil, the IQAC coordinator of the college, to encouraging us to carry out these events. Then, thanks to Professor Captain Mithilesh Rathod, the coordinator of the research committee. Thanks to resource person Dr. Professor Nandakishore Karde and Dr. Pratipji Tekade for sharing their knowledge and expertise in the fields. Thanks to all the participants, all the heads of the various departments and the organizing committee. Last but not the least, we are grateful to the technical committee. In addition, we are thankful to Dr. K.B. Raulkar sir, Dr. A.U. Chavan and Aditya Lunge for performing all the technical aspects for the smooth conduction of this event. With this word, once again, I thank to each and every person who has contributed knowingly or unknowingly in the success of this event. Thank you. Thank you. Meet you again.
All the participants are requested to fill the feedback form so that you will get your e-certificate on your email address. And with the permission of the chair, I declare the webinar is over. Thank you very much.
Thank you.
Sure.